This is Algebra 1, Lesson 3.1. In Griffith Park, which is in Los Angeles, California, there is one of the largest city parks in the United States. You could spend days, hours. There are miles of hiking. There's a theater. There's an observatory. In this lesson, we will see how to solve equations to find out the size of some city parks. You can solve an equation by writing an equivalent equation that has a variable isolated on each side. Linear equations are equivalent fractions and they are in balance. When we get all the way through, we get them in balance. So let's take a look here at what we're doing. Let me change my ink pad here. Okay, so in this first example right here, we have 3 plus 2. We have 3 red ones, 2 blue ones, and that is the same over here as 5 white ones, whatever those are. And so it's in balance. It's 5 equals 5, and there's nothing more that we need to do about it. But let's say that we had the equation of x plus 4 equals 6. Well, we can't make a whole lot out of that, let's say. So we got to make it balanced. And so the first thing we do to make it balanced is we subtract 4 from this one and do the same over here. So now we have x equals, x equals 2. And if you take a look over here, you can see that it illustrates this part. We have x plus 4 minus 4 means that the 4's cancel each out and you're just left with the x here. Over here, we would have started with 6 milk bottles and we've taken away 4 and that would leave 2, and now x equals 2. So when we talk about transforming equations, the first thing we want to talk about is how do you solve a linear equation. You already have done this multiple times, but let's just go over the basics. First, you simplify the algebraic expression on each side. You collect all the variable terms on one side and all the constant terms on the other side. So you want to get all the x's on one side and all the non-x's on the other side. Then you isolate the variable. You get x equals, and then whatever, you solve that, and then you check the proposed solution back into the original equation. So let's look at some original equations and then compare that to what the equivalent equation would be. In this case, we have, first one, x minus 3 equals 5. We want to get an equivalent equation, so in this case, we will add 3 to both sides. That will give us plus 3, and then we end up with x equals 8. Okay. Let's look at the next one. We have x plus 6 equals 10. Because this up here, this one was a negative, it was obvious that the opposite would be plus 3. Here it's a plus 3, so now we must use a negative 6, and now we're going to have x equals 4. So up here, the operation to make this equation equivalent was to add a 3. Over here, the choice was to add a negative to both sides. And then the last one, we have x equals 8 minus 3. And now we must simply simplify here, because we don't need to add or subtract. In this case, we're just going to end up with 5, and so x equals 5, because the x was already isolated over there. Okay, so we're going to talk about inverse operations. Inverse operations are addition and subtraction. They cancel each other out, basically. They help you isolate one variable onto another side of the equation. If we look at our example here, which is solve x minus 5 equals negative 13, the first thing you have to do, and you do this when you're doing your homework, so please make a note of that, is you write out the original equation. And then we are going to add, oh sorry, hang on, something popped up on my screen. Golly, x minus 5 plus 5, and then we're adding 5 to both sides. And now we can, so here we added, and here we're going to simplify, solve here, and we end up with negative 8. So we wrote the original equation down, we added 5 to both sides, and then we simplified. Now the final step is to check our answer, which is we put negative 8, I don't know where that dot came from, but that's okay, minus 5 equals negative 13. That is negative 13 equals negative 13. Okay, so let's say that we have negative 8 equals n minus negative 4. And so here's our order of things we're going to do over here on the left. We're going to write the original equation. We are going to use the subtraction rule to simplify. We're going to subtract, and then we're going to simplify. And then, of course, the last thing that we will do is to check our answer again. So we have we've written the original equation. We now can simplify. We can use the subtraction rule to simplify, because this is going to be a plus 4 there. Now we can, so we've done that one, and now we can subtract from each side the negative 4. So now we would have negative 8 minus 4 equals n, and now we can simplify, and that would give us negative 12 equals n. We can plug that back into our original equation and see if it works. Negative 8 equals negative 12 minus 4. And we can change this to this side of the equation to negative 12 plus 4 when we simplify that, and we have then negative 8 will equal negative 8 on this side, and it works. So let's look at some examples here on solving an equation, and I worked some out for you up here on this example here. Hang on. Okay, I was having some technical problems with my dot there. I didn't want on here. So in this example, we have negative 2 equals x minus 4. And so now we are going to subtract or add both, because this is negative 4, we will add a positive 4 to both sides, which I did there and there. And when I then solve that on each side, I get 2 equals x. Now if we go back and see if that works, is that the solution? We have negative 2 equals the 2 there, minus 4, and that will be negative 2 equals negative 2. So that one does check out. Over here we have another problem. This is x minus negative 9 equals 6. And right here we can simplify this using the subtraction rule. So this is x plus 9 equals 6. Now I can try to isolate the x. So I subtract 9 from both sides. So that's x plus 9 minus 9 equals 6 minus 9. And that ends up to be x minus 3. So let's see if when I put that into the original solution, if that works out. And you can see here that negative 3 plus 9 is going to be 6, and that will equal 6. So that one checks out. On our last example up here, we had y plus 5 equals negative 1. And we want to subtract 5 from both sides to get the y isolated on its own. So we end up with y plus 5 minus 5 equals negative 5 minus 5, and then that works out to be negative 6. Y equals negative 6. So let's see if that checks out. We will put negative 6 plus 5 equals negative 1. And we can already see that this will be negative 1 equals negative 1, and so that checks. So let's look at the difference between a linear equation and what is not a linear equation. Here we have x plus 5 equals 9, y plus 3x minus 9. In all of these, they have a exponent of 1. Over here, these are not linear equations because they do not have an exponent of 1. So a linear equation equals an exponent of 1. So you're not going to see the little number there at all. Now, linear equations model MIDI real-life situations. I wrote equations there. I meant situations. Linear equations model what happens in real life. This is a picture of Spearfish, South Dakota. It's located in the Black Hills in South Dakota, and you can see these big rocks. Well, the temperature is has such a variation. The freezing from frigid cold to the thawing causes landslides, and you can see these big old rocks that then land at the bottom. Hang on, I just knocked my draperies down. We have real-life examples that we can work out using linear equations. We're going to start with, something relatively easy that you could probably do with mental math, but let's talk it through anyhow. So, in Spearfish in 1943, on January 22nd, the temperature at 9 o'clock a.m. was 54 degrees Fahrenheit. At 9:27 a.m., it was negative 4 degrees Fahrenheit. So we're only talking 27 minutes here. And we can now, so I sort of verbally wrote this out. We have 927 degree temperature equals the 9 o'clock temperature minus the degrees fallen. So let's sort of label this, put our labels down and see how we would work out. Even though you can do this mentally, I want you to follow this process because it sets you up for harder ones. So the coldest temperature was the last temperature. That was 927. That was negative 4 degrees Fahrenheit. The temperature that started was at 54 degrees. That's pretty good playground weather here in Cheney. And the degrees fallen, we don't know, so we're just going to use a T for time. So I've labeled everything, I've used my verbal model, and now I can turn it into the algebraic model. And I can say negative 4 equals oh, I wrote that wrong. Negative 4 equals 54 minus t. I can I'll isolate my t, so I will subtract 54 from both sides. Okay. Now I have negative 50, and I'm left with t, and it's a negative t, and now I need to simplify this and get rid of my negative here, so I'm going to divide both sides by 1, and I end up with 50 equals t, and so the degrees from 9 o'clock to 9:27, the degrees that the temperature fell was 50 degrees. It fell 50 degrees. And so we worked it out correctly. We had a verbal model, we labeled our verbal model, and then we worked it out algebraically. So let's try another one. A record 24-hour temperature change occurred in Browning, Montana on January 23rd and 24th in 1916. In that time period, the temperature fell from 44 degrees Fahrenheit to a negative 50 degrees Fahrenheit. So we're going to set up the temperature on January 24th, which was the latest date, was 50 degrees Fahrenheit. And that's going to equal 44 degrees Fahrenheit minus t, because we don't know the degrees fallen, and we'll work it out the same way. So this one is the January 24th date, and this is the temperature, and this is the temperature that they started on January 23rd. Now I have my equation, and I can start solving. So or simplify. 44 minus t plus 44, negative 56 plus 44 when we get add 44 to both sides. That leaves me with t over here. And then I will have negative 1 here. I forgot my negative here for my t. I divide by 1, and I end up with 100 equals t, and it fell 100 degrees. So let's just kind of go over the concepts that we talked about. Linear equations are, with the same solutions, are called equivalent. If I can spell it at the moment. I'm trying to hurry because the Super Bowl is on, and I need to leave to go to a party. The next one is inverse I can't spell it. Inverse operations are such things as addition and subtraction, where you do it to balance the equation to make it equivalent. Linear equations are an exponent of 1, so it's not anything squared, cubed, or anything else. It's always just a linear exponent is just, I want to say invisible because there's no little number above it. But when you are doing word problems, remember that so when we were doing the temperature changes, we went basically with the last temperature and then the equal sign and then the first temperature minus the unknown value, which was t. And so if you're trying to find money, how much money was spent or whatever, you're going to do the same thing. You're going to, on one side of the equation will be what you ended up with, and the other side of the equation is going to be what you started with minus the unknown value. So T for time, M for money, whatever. Okay, so your assignment is on page 135 to 137 in your book. Exercises 22 through 24, 31 through 36, 46 through 48, 53, 57, 60, 63 through 78. And on your assignment sheet, you need to write down on the top line, this is a new rule, what the assignment is. That way, if you have to take it home and finish it, because all homework is due the next day, so at the beginning of class. So if you don't finish it, you have to take it home and turn it in the next day. There won't be any more class time given for to do assignments more than one day. This is so that you can be ready for geometry when you go, or whatever Chini offers, so that you'll be ready for it when it's there. So good luck, and let me know if you have any problems.